Okay, so tangent segments and walk around problems. So we kind of went over this yesterday, but now here's the theorem behind it. If two segments with a common endpoint exterior to a circle are tangent to the circle, then the segments are congruent. So if you're looking at this, these are tangent. That means AB is going to be congruent to AC. Okay. Yesterday we learned that if we have a line or segment that is tangent to the circle, the radius should be perpendicular with it. Okay. So looking at example 1, find DG. Well, we can't really do much with the radius because we don't have anything there, but we do know again that this is congruent with this. So we're going to do 2x minus 4 equals x plus 7. So in this case, we're going to get x is equal to 11. Now remember that GF is going to be congruent with DG. So DG equals, bless you, x minus 2, which is 11 minus 2, which equals 9. Any questions on this? All right, example 2. What is the perimeter of A, B, C, D? So again, applying this rule means that we have 90-degree angles here with the radii. That means we have tangent lines. So this is congruent to this, making this 7. This is congruent to this, making this 2. This is congruent to this, making this 3. And this is congruent to this, making this 6. We add them up. We get, let's see, this looks like, 13 here, 5 here, 9 here, and 9 here. Perimeter, remember, is adding all the sides. So this is going to be 13 plus 9 plus 5 plus 9, which gives us a total of 36. Now, before I move on to something a little more complicated, are there any questions on these two that I can address? Because you got to have this basic concept for the rest of it. It'll be a lot easier if you do, believe me. Are there any questions? I don't see a Navi, right? She's not here. No. Okay. Just double checking. Okay, let's move on to example 3. Now, this is telling me that the diameter of circle F is 8, which means that I have a radius equal to 4 here. That's going to be important in a minute. They're saying AB is 10, and AB, BC, and AC are tangent. So we have this point of tangency that creates these right angles. What is the perimeter of triangle ABC? Well, how do you find that when you're not given the whole side? Use the radii to help you. So if I do a radius here and here, I know that those are going to be perpendicular, right? Creating a square. So if this is 4, this is 4, but that also makes this part 4 and this part 4. And now we have something we can go off of to find the rest. Now remember, this is going to be congruent with this, so this will be 6. And this will be congruent with this, making this 20. So our totals are going to be 26, 24, and 10. So our perimeter is going to equal 10 plus 26 plus 24, which gives us a total of, very easy, easy peasy, lemon squeezy, 60. That's it. Try this one on your own. And I'll show you the answer in a few minutes. Yeah.
How do you know how to draw your lines in the circle for the radius?
Well, I know that they're tangents, so I'm going to have something perpendicular, right? And I know all radii are congruent. What it's going to be based off of is what you are given. In this case, I was able to do this, and it gave me at least something, and it was easiest in the corner. Is that always going to be the case? Probably not. But you can create like maybe triangles to help you out, things like that. Does that kind of make sense? Yeah, it's all going to depend on the problem you get. I wish I had a more direct answer for you, but sorry, it's math. Show of hand who is still working on the try it. All right, let's check it out. Oops, the wrong one. There it is. No, okay, let's try this again. Where the heck? Oh, it's over here for some reason. Oops. Okay. So here you go. Should have gotten 46. Now remember, you could have chosen, the reason that's there is because you could have chosen either side. All right, that's why there's two squares there, but you did not have to use both squares. It's just you have options available to you. Any questions? Okay, let's take a look at the bottom. Okay, so in this one, we're not going to try it together. I just want you guys to note, we're going to have this on the back side too. But if we look, it says circle E is inscribed in ABCD, and BC is equal to 16, CD is equal to 12, and AD is equal to 20. Find AB. If you look here, we do not have any of those smaller parts. We only have the larger parts, or most of the larger parts. We don't even have the full thing, right? So this is a little different. So we have to do a different procedure. And this is called a walk around problem, where you start at one area and you literally go around the problem and calculate other sides. Okay? So that's what I'm going to have you write down right now. This is the walk around procedure. First thing you're going to do is mark all the tangents on the diagram congruent. And that's that whole point out in space idea. Okay? Label the info that's given to you. Label one of the parts of the missing side as X. Start with X and walk around the figure labeling points. And when you finish all labels, add the two segments of the missing side together. I know this might seem a little complicated right now, but I promise you it's pretty easy. Anybody still writing this down? Okay. Okay. Anybody still writing? Okay. So let's take a peek at this problem now that we have this. Okay. So what's happening here is, again, I'm going to mark a bunch of things congruent. So in this case, I'm going to have this is congruent with this. This is congruent with this. This is congruent with this. And this is congruent with this. Now, if you don't want to mark out all the tick marks, you could always just use different colors. That helps too. Okay. Now, I'm going to write in the information that's given to me. They're telling me B to C is 16. let's see, we got C to D is 12. We have A to D is 20. And this is the side we just don't know. So my first step is going to be to define some, we have unknowns, so we're going to define one of these sides as a variable. You can kind of start wherever you want, but my tip is probably start with a part that the line creates and makes your life a lot easier. Okay. So I'm going to label this as X, and if that's X, that means this is X. And then I'm going to walk around the problem. So looking at this line segment, I see that this is going to be 16 minus X. And since it's congruent, this is 16 minus X. Now this next part is going to be 12 minus the quantity 16 minus X. Do not forget your parentheses. That is important here. Because when we simplify, we're left with negative 4 plus X. And now this side is going to be 20 minus negative 4 plus X. Which ends up being 24 minus X. Is everybody with me so far as to where that all that came from? Okay, so now we're going to add these together. So this is going to be AB is going to equal X plus 24 minus X. Cancel the X's, so AB is equal to 24. Does that make sense? I want to leave this up just so you have it, but I want you to try the next one on your own. It says a circle inscribed in PNHS, NH equals 12, HS equals 15, PS equals 18. Find PN. Go ahead. All right, any questions on this? Anybody still working on that one problem? Ready to look at it? Okay, so here's the try. You should have gotten 15. And here's the work behind it. Questions on this? Okay, let's take a look at example 4. So I want you to write this down. Note, you can start at any radius to walk around. Our x may differ, but all radius end up being the same. Okay, so that's just a note I want you to write down. You can start at any radius you wish. And then we'll go over this in just a minute. It's all in pink. All right, everybody still writing what's down in pink? Okay. All right, let's talk about this. So it says 3 circles, circle A, circle B, circle C, are externally tangent to each other. So it says AB is equal to 16. So this side is, oh my gosh, come on now. 16. BC is 12. And AC is 11. So here's our sides. Now, one thing we know about all radii are congruent, right? And each of these has two radii coming off of each circle to create this triangle. So this and this are congruent. This and this are congruent. And this are congruent. Now remember, this is a walk around problem, so we got to define something as x. I'm just going to pick this. That's x. That makes us part x. That makes this part 12 minus x. That makes this part, let's see, 16 minus 12 minus x, which leaves me with 4 plus x. So this is 4 plus x right there. Now, here's the thing you want to look at. If we look here, we got to like do something to like add this together to solve for x. So I'm going to just look at AC because this is kind of where I landed, okay? So I'm going to have AC here is going to equal x plus 4 plus x. So I'm just adding this whole side together. And I know it's going to equal 11. Because that's what we said AC was. So this will be 2x plus 4 equals 11. And solve, you're going to get x equals, oh, no, sorry, equals, not plus. X equals 3.5. So if we're talking about a radius, this is the radius of circle C is 3.5. That's easy because we labeled that as x, right? The radius of circle B is going to be 12 minus 3.5, which leaves us with 8.5. And then the radius of circle A is going to be, what do we have here, 4 plus x. So 4 plus 3.5, which leaves us with 7.5. Okay? Questions? Anything? Okay. Your homework is the half sheet that was passed out. It's those 5 problems. If you are done with that, please make sure you have the homework at least 75% done from yesterday. Okay? So, as in, I want your score to be at least 75%. Okay? Sound good? Questions? All right, that's it. Those who are watching at home, have a great day.